So yes, I thought I would take a challenge and try to title a talk that there's no way spring days would accept. Spring didn't invent it. But it turns out they are open to that heresy. And so the point of this talk is partly who here is new to spring? Who here is never, okay, so we got some people. I mean, yeah, spring is there, and your experiences have probably not been as easy as you might like, right? We'll just sort of dive into, I spent a lot of time preparing for this talk. I ended up spending a lot of time on sites labeled, "Why is learning spring hard?" And "I hate spring," and "Why not spring?" People are struggling to understand how spring is helpful. It feels cumbersome in a lot of cases. There's a lot of people who claim that I don't need spring, I'm fine without it. And yet, we're here today because obviously over its lifetime, it's brought a lot of developers. It makes them feel productive, right? We talked about how many things we think we can do with spring now, the renaissance that's coming with cloud. So I kind of want to bring this talk, and I'm glad that I'm starting it early, because especially for you new guys, or anybody out there who's suffering with spring right now, and doesn't want to admit it in the room, I can understand that, but this chance is your chance to talk to the wizards of spring. And the truth is that spring is magic. But like any true magic, you have to learn it. If you learn to understand it, it becomes a tool, as opposed to that black box that you dare not go. And this talk is kind of, what it turns out is that spring has a cohesive story to it. It has a set of standards that if you're not paying attention to in the documentation, you'll skip over. Spring, the documentation doesn't tell you about all the backstory of spring, all the pain that happened before spring. You kind of have to talk to people in the field to understand what spring brings to you and when it's okay and when it makes sense to have spring be that magic that you want it to be. So the challenge to people who are new, especially new to spring, this talk is for you, and it's designed to help give you conversation starters with all the wizards in the room, right? I want to give you that common language with them so that you can ask questions that help you dig beyond spring. Because at the end of the day, if you're going to use spring in your job, maybe another 5 years, maybe another 10, maybe spring becomes a framework that never dies, but there's a lot of other frameworks out there. And the chance that your career is going to last entirely with spring, I'm kind of hopeful that that's not true, that you'll see more variety than that, which means that you need to go beyond the framework to the fundamentals of it. Because if you study what spring has brought to the table, if you study the why behind a lot of the technologies, you find out that spring didn't invent it. Spring is bringing to the table a lot of best practices, a lot of pain, a lot of suffering that was made easy. And they're upfront about this. This is section 2.1 in the spring overview, right? Spring is formalized design patterns as first-class citizens. Spring didn't invent many of the things that spring brings to the table. It's taking lessons from the best of the best and helping you use them. And how do we know that spring didn't invent it? You told me yesterday at the thing, when was the last time something new in software was developed? Lisp, right? It's okay that spring didn't invent it. There's a lot of good ideas that have been very hard to use, and now, but that learning curve, that's where you find the spring learning curve, is the struggle to catch up with all of the history that has happened to bring spring to the table. Okay, so for the new guys, if you haven't heard of them before, a design pattern is just a general, repeatable solution to a commonly occurring problem in software design. What this means is that for every pattern that you see in spring that we're going to talk about or that you hear about, or for every technology, there's a story behind it. There's a problem that needed to get solved, and Not going to read about that problem, but you probably can get people to tell you the story of the bad old days. Now, for Spring, and I think this is important when people start comparing the complexity of Spring to other opportunities or just plain old Java, is the commonly occurring problem that is enterprise-ready applications. What, not even a laugh at that? Nobody recognizes that. It's too painful to even recognize, right? One of the things that Spring has always put as a first-class citizen is that idea of enterprise-ready. And enterprise-ready is kind of a special animal, right? Your application is going to live beyond you. Your application is going to live beyond your current customer. Your application is going to have conflicts of opinion. It's going to struggle with language barriers and time differences and technology changes. Your application in an enterprise-ready application has to survive change. And this is one of the first-class citizens of Spring, is dealing with change. But Spring did not invent change, and it did not invent the solutions to change. The patterns we're going to talk about, clean code as a pattern, the core patterns that evolved out of dealing with change. Some very, the contributors to Spring, the people who bring you these modules, they're well steeped in the lore of these technologies of clean code patterns. And if you're not keeping up to date with those, you're going to miss out on a lot of the subtleties that Spring can bring you. You're going to find it hard to know where to read and where to go, because this informs you about how Spring is built. The other challenge you have with Spring and the complexity is that Spring oftentimes didn't invent the technologies it's bringing you. So there's always that extra learning curve anytime you're diving into one of these large modules to understand the design patterns, the technological trade-offs that they had to make in order to deal with large complex domains like batch, like web, like REST. And so with Spring, your challenge is, again, it's not to just learn Spring, it's to dig one level, at least one level deeper, and actually dig into what it takes to be a good developer across any technology. Now, the good news is if you do that, you can use any technology. Okay, so a little more in depth. Enough of the overview, let's go into depth. Spring did not invent clean code. Anybody want to give me a name of who did invent clean code? Okay, we got Uncle Bob Martin, absolutely. Michael Feathers, anybody a fan of Michael Feathers? Anybody else? Dijkstra, Dijkstra was a clean code, right? It goes way back before Java, way back before object-oriented, back to the foundations of much of what we learn. And the point of clean code is back to that point of change, right? Because you know what happens, right? You've got the design. Your application is going to be fast. You're going to be able to make changes like that. You're going to keep up to date with the market. But what do we actually encounter in our code? The big ball of mud. And Uncle Bob is very clear about what happens here, right? We don't start out to write bad code. Okay, most of us don't start out to write bad code. We end up there because of change, because we take that pristine green field and we start to have to tweak it, and we're under time pressure, and so we make a hack, and we don't quite understand the abstraction, and so we kind of just go for it. And what happens is eventually you get the big ball of mud, where everything touches everything, and you can't make a change without breaking everything. In order to combat this, what is proposed for clean code is a series of patterns involved with refactoring, bringing your code up to speed. And Spring, as a framework, makes heavy use of this. Uncle Bob, everybody talks to Spring. What's the first thing you hear about Spring? Dependency injection framework, right? Dependency injection does not happen on its own. It is actually part of this clean code pattern. So, thanks to a group called Los Techies, we're going to have a little bit of fun with the acronym called SOLID, which is a set of 5 mnemonics to help you think about clean code. And then we'll be able to take a look at some of Spring and think about where these techniques are being applied in Spring, which helps you understand then how to approach the module yourself. or at least it has worked that way for me. So, SOLID is the acronym. D in there is the dependency injection. It starts, though, with single responsibility. Yes, we've all been in that method that does everything, right? We've all been in that class that is the God class in the application, and everything goes through it and comes out of it. Single responsibility is the practice of decoupling that, is the practice of making sure that whatever code you're writing, whether it be a method, a class, a package, or now in the modern age, the microservices, has one and only one cohesive reason to change. So some other things you've heard about this, it spans the run of making things small and single purpose, but it also then, I think, talks about once and only once, right? If you've got something that changes for one reason, well, you don't want to have to go change that everywhere. So how do you corral that in and make your code dry and have a single responsibility for an area that you can then reuse across code? The open-closed principle. This is one of those ones that if you're reading in Spring at any point, they make a big point to have you link out to Martin Fowler's comments on open-closed principle, because it really fundamentally informs a lot of what they do in the framework. They build their framework so that you can take it and extend it. They make it open for your reuse and for your extension, but they keep it closed, right? The idea is you don't have to go into the guts of Spring. You're not even supposed to have to decompile, open a class, and then recompile your own version of Spring. You shouldn't need to do that. And that's the open-closed principle, that you try to design your software, your single responsibilities, so that at the same time that they're cohesive, you can still, at the point where you know you have to make changes, inject new code. And that's the beauty of open-closed, is that if you really strive to keep it, you're always adding new code, you're not modifying code. And this is a great time saver for that enterprise app, because now you're not having to regression test everything. You're leaving the tested code alone, and you're bringing in new functionality and only have to worry about the boundaries of that functionality. Okay, the most technical of this is the L, the Liskov substitution principle, which is kind of, I don't know, there's not a lot of good examples of it described out there. People tend to skip over Liskov substitution. But it is very important to recognize that if you're going to modify something and reuse it, you've got to keep to the spirit of it. You've got to maintain its capability for, got to not surprise people and make them add things to it to use your version of it. We'll just keep going. Interface segregation. So another key point is you've got to be kind to your clients, right? I think this is really what caused the death of service-oriented architectures in the past, is nobody ever thought to segregate their interfaces. Instead, they just kept piling on method after method, feature after feature into one giant ball of mud. And it's not fair to your clients to make them know that, well, if you set this property and use this method here, then this one isn't legal anymore, and then they end up having to know everything about your business logic, right? Interface segregation in these days with the microservices is becoming very popular again. The idea of the contract-driven architecture, the idea that you give the client exactly what they're asking for, and you yourself control all of the mapping and underlying craziness of it. So keep things simple and small. And of course, then, it ends with dependency inversion principle, or dependency injection principle, right? The thing that Spring also touts. But if you see how it builds together, right, you can't have dependency injection if you don't have some sense of interfaces being segregated. You're not going to get dependency injection if you can't trust that your substitution principle is being violated. You have nothing to inject if things are not small or open for extension. So all of these principles are found within the Spring library, and all of them become an important part of your code as you're writing to extend the library. If you're not maintaining your own code clean with Spring, I kind of think of it's like pouring concrete over Lego. You're putting a bunch of blocks together and then you're never going to be able to pry any of them out. You're stuck with your business logic or you're stuck with your application. And you don't see the benefits of Spring at that point. Okay, so this is the list. For those of you, you can find it online, Google it at home. There's lots of documentation on all of these. Okay, so with that in mind, that Spring didn't invent clean code, what else didn't Spring invent? Well, it turns out Spring didn't invent externalized configuration, right? This is a classic pattern, again, coming out of clean code, that no matter what you do with your app, no matter where you run it, if you can't put it into an environment and read something about in that environment that's going to influence what it does, why you're writing the app? It's not going to do anything for anybody. So back in the day, you would develop your own code and you'd figure out a couple of ways that you'd work out with your ops team, how they would tell you host names, port numbers, security protocols. And you'd probably pick 2 or 3 of these options depending on which one they felt they wanted to support as an ops team. And eventually you'd end up maintaining duplicate properties in many, many places. You'd have this copy and that copy, and there was no way to rationalize them together. So you'd have to keep putting copies, you'd have to keep changing that same property in multiple files. Or worse, it'd be in production, you need an emergency change, you'd forget that you would have forgotten to implement the override, and suddenly you've got to go rewrite your code, pull it out, and give them a way to change that property. None of those are a great way to live. So Spring configuration is one of those things that there's so many options right now. Now, Spring didn't invent, okay, maybe a few of these are Spring specific, obviously, but the general concepts they did not invent, right? They brought together the best practices that had been seen across many enterprises and many experiences, and they gave you the extra advantage that there's a logical system of overrides so that I can keep my properties in my property file, but if my ops team needs to make a change, they have a way to inject it, right? Dependency injection again. Interface segregation happens with this, right? If I'm going to design my configurations, I should probably think about what has to change at the same time and make sure that I don't try to pile everything into one file, because then I'm constantly changing that one file. And Tim's here, and I know he'll go into that in depth in his talk. So we see, again, the same patterns happening here. The clean code leads us to the idea of how do we work with an externalized configuration? And if you're working on your team, again, you don't have to use all of these methods. You're going to pick the ones that make the most sense, and then, but be aware that you can push things back and forth. You have flexibility with Spring without having to code it yourself. Okay, my favorite, because this is where I've spent all of my years of programming, is Spring did not invent the web. Yeah, in fact, it's more like the web invented Spring. So back in the day, I showed this slide because this is the original Java web stack as it's described by Oracle, right? It's a nice, clean architecture. You have servlet container sends messages down to your servlet, get responses back, sends them out to the web. And you have this fantastic, flexible way to do that, to add customizations where you can add filters. So you have these long chains of everybody taking a little snippet, single responsibility is maintained, open and closed is maintained, because I can have that chain snip, snip, snip the request down to some business logic and return it back out. So works great. And for some cases, that's all you really need. You don't need Spring. But what's the challenge with this particular architecture? Dependency injection. How do you inject dependencies in here? These classes are built and constructed by the container. Their life cycle is managed by the container. You don't get control over them. You just kind of have to hand them out. So Spring struggling with this, and pretty much every other framework ever invented to lay on top of Java Web decided to use a common pattern called the front controller. And when you're working with Spring in the web, you really want to understand what's going on with this front controller, because you're over here writing. You see an arrow? No, not really. Okay. You're over there in that yellow circle called controller. That's, if you're reading Hello World examples, if you're reading the examples on the web, that's the code where you get to write. And there's all of this other stuff happening, and all of these lifecycle points happening in the front controller. Now, the good news is, there's some very good reasons why the front controller, right? The first one we talked about before, right? It's the only way you have to hijack the control from the container so that you can control your application, inject your dependencies, have a logical lifecycle of how that's going to work. The other thing, of course, is centralized control. Again, if all you're doing is a single request microservice, you're probably not as excited by this as I am. But if you're doing multiple requests over time, if you're trying to support this, if you're trying to do contract-driven development and support multiple different interfaces, but not have to write custom code for every single interface, then you want to be able to share logic across your controllers. Another thing that's going to happen under the hood of Spring that you're not necessarily aware of is all the thread safety. So is HTTP session thread safe? Anybody? No, it's not. It's not thread safe. Spring has done a very nice thing. They've abstracted enough of a way through that front controller that they can create copies that let you work safely in a thread and then worry about reconciling that with the main HTTP session later. And of course, the configurability aspects of it, right? You have essentially, with Spring, it's 20-something different ways you can change up how the Spring behaves. So when you start to see in your own controllers, if you're writing more than one, because, you know, this is the new world of microservices, that you're seeing the same patterns, you can extract those out and put them either before or after using any one of these injector patterns into the main body of the dispatcher. So you get that flexibility of the servlet filter without actually having to write necessarily servlet filters. Plus, you also get, you know, this is single responsibility in action. Single responsibility plus open closed. Okay. So Spring also didn't actually invent beans. Beans are a very old Java construct. And at the beginning of the day, they were really all about configuration and dependency injection, right? A Java bean was just a convention, a way of structuring your method names, making sure that you could construct an empty object, and of course serializable for a variety of reasons, that would support this magical thing that Java brought to the table called introspection. And introspection was awesome because introspection would take your Java object, look for those patterns, and then do things programmatically to them without you having to go write every single line of get and set. And it was so that these beans could exist as a concept that could be sold, reused. It was coming out of the days when we had great visual UI development. They wanted to have that pretty easy WYSIWYG, you know, click a bunch of properties, set the blue, set the green, and have these things reusable. And then they got evolved into the now infamous enterprise Java bean, which started out as a great concept. I'm going to be able to write some code, and I'm going to be able to sell it to you, and you're going to just install it, and it's going to run in your system, and it's still going to be my code, and you're going to be able to use it. And so, of course, when Spring got started, the components that Spring created to manage got named beans. That's all there is to Spring Beans. And you'll see some of the patterns happen with Spring Beans. The old, now who here is like purist for dependency injection via constructor? Okay, we got a few. Who here still uses the old setter method styles? Okay, we got some, right? The setter methods were very natural back in the day. That's exactly how we kind of worked it out. And that was the original thing, because again, until Java kind of came up to what Spring needed, Spring was stuck setting methods, working with introspection. And now, of course, it's a much more powerful container with a lot of flexibility for how to manage your beans. So another area to look into is what are all the different ways you can manage the life cycle of beans with Spring? Okay. So that pretty much concludes where I was going to go with this, the canned part of the talk, and we can open it up. I'm kind of curious about stories now. You know, what else has Spring not invented that you find it helpful to understand sort of the core infrastructure of? Didn't invent MVC. No, it did not. Yep. And what problem does MVC solve? So this is actually, yeah, we're getting into MVC now. I had a great talk about 2 years ago at Connect Tech that I don't know that MVC isn't actually on its way out the door, because in the new world order, I mean, MVC originally started on this idea of the desktop. And what we call controllers today don't really feel like controllers if you look at what controllers were back then. There's, oh man, I should know his name because it's very obvious and it's fading on me right now, but if you look up, if you Google action domain responder, you get a very interesting pattern that starts to talk about like this new thing called Flux. Anybody excited about Flux? There is a Spring Flux project I saw. So again, Spring didn't invent it, but if it's useful, it'll help you find it. But yeah, the idea that MVC and talking about controllers tends to lock people into views, and this idea of action domain responder opens up the concept of what you're actually talking to, because you're really not just talking to a web page anymore. Now you could be talking to a phone. You could be talking to a controller of your HVAC system. You could be talking to a whole range of devices that have nothing to do with a traditional view, and it's not helpful to be able to think of a flexible system that's, you've got an action, your controller becomes your action concept, you get a request for something, your domain is still your domain, model domain, and then your responder can be whatever it needs to be, again, on whatever protocol it needs to be for that matter. So Chris, what does, well, I guess you'll be talking about this. So the questions are for the speakers, you know, are you guys going to tell us about the problems that you're trying to solve, right? When we get into like things like Spring Batch, or now the new Spring, I'm forgetting what it's called, the Spring Flow, reactive? Yeah, Spring Cloud Data Flow, right? You know, a good chance to talk to these people about what it is that they're really trying to solve for. What are the patterns that they use? Because if you understand the patterns, you understand where to go look in the code, right? If we go back a couple to MVC configurer, a challenge you have working in the web is you're never quite, you know, you get to a point where you just feel boxed in that controller. And you're struggling to figure out how to make your change reusable, or you keep seeing the same thing over and over again. Single responsibility, the idea of a decorator filter pattern within the front controller gives you a pretty clear idea of what to start Googling for in order to figure out where to inject your change and how to use it appropriately.